Yesterday we did concave, and we saw that yesterday this is the reflective part of the mirror. So this is where you're in. So the object is obviously in front. So we always had our frame of references. We had the center of curvature of radius of curvature. The focal point was half of that, and we called this up positive, down positive, and then measuring in front of the reflective part of the mirror was positive, and then into the mirror was negative. All right. So today we're going to do something a little different. Today we are going to look at convex. Okay? So convex means it's going to shape out, but go outward. So here, what's going to happen is when we do the problems mathematically, our sign convention is going to be different. So with convex, if this is the part of, if the object is over here and this is the reflective part, because the object has to be in front of the shiny part of the mirror, if I was to make this mirror into a circle, you see how the center of curvature is on the inside? So the center of curvature is actually negative, all right? The focal point is negative, because from here over, this is going to be negative, and then di is going to be negative. With convex, we're always going to have upright, virtual, and smaller, okay? But what we'll do is we'll start off and just work one of the problems, and then we'll look at some of the things in a minute. So let's start off and just do C1, okay? So C1 says, the image of a crayon appears to be 23 centimeters behind the surface of a convex mirror. So when we write our given, di is equal to negative 23 centimeters. It's 1.7 centimeters tall, so hi is equal to 1.7 centimeters. If the mirror's focal length is 46, now remember with convex, because of the sign convention, it's always going to be negative. So this is negative 46. How far in front of the mirror is the crayon positioned? So I want to find DO. What is the magnification? I want to find M. And then is the image real or virtual? And then is it upright or inverted? So then I would also find HO. Okay, so I want to do just about everything in this problem. So there's actually a lot to do. So for the first part, I'm going to use the same equation, that 1 over F is equal to 1 over DI plus 1 over DO. And what we did yesterday was we looked at the algebra for rearranging the equation to solve for the unknown in terms of the known. So I'm going to skip all the algebra steps, and I'm going to write the equation DO is equal to DIF over DI minus F. Now when you're substituting these values in, what you have to do is you have to be very careful with your sign convention. So with the negatives, it makes a huge difference. So this is going to be negative 23 times negative 46. And now you see why this makes a difference, because a negative times a negative is a positive. Over negative 23 minus negative 46. And also remember, a negative times a negative times a negative is a positive, so this is going to be an addition. So when we do all that, it comes out to be, DO comes out to be 46 centimeters. So that's the first part. All right, then they asked us for the magnification. So the magnification is actually like two parts. The magnification is each is HI over HO, but we don't know those. And it's also equal to negative DI over DO, which we have these two. So it's going to be negative 23 divided by 46, which we just found, and that the negative times the negative is a positive, and we get 0.5. Now they ask me questions like, is it real or virtual? Is it upright or... So, first of all, the image is virtual because DI is negative. And then they asked if it was upright or inverted. Well, the magnification tells us that. So this magnification is positive. So the image is upright because, and I'm just writing the because, so when you go back and look and we do the other problems, because M is positive. So if M is positive, it's upright. If M is negative, it would be inverted. And then the last part told us to say, it asked how high is the object. So that's HO. So now, because I already found the magnification, I'll say M is equal to HI over HO. And I'll rearrange this and say HO is HI over M. So it's equal to 1.70 centimeters divided by 0.5. So the height of the object comes out to be 3.4 centimeters. So in this problem, basically we used all the equations for optics, okay? We use this first one. Then we use the magnification equation. The only one we actually didn't know is that you need to know that the focal length is equal to C over 2 or R over 2. Because remember yesterday we were talking about, you know, sometimes the book calls it the radius of curvature instead of the center of curvature. Okay. Oh, you couldn't see that. Whoops. So this was a good exercise in practicing. So the difference is, again, that with your sign convention for convex, you make the focal point negative, the center of curvature is negative, and DI is negative because it's on the circle's on the other side the way it's bending. Okay. And that's it.